Hello friends, now I welcome you all in the explanation of phases of compiler. So this is also called as phase diagram of the compiler or compiler diagram of different phases. So here, as we have discussed in the last video also, the input to the compiler is a high level language program, that is also called as source program or source language program, and output is a machine language program, or it is also called as target program or assembly code. The compiler works as a translator between high level language and machine language. It works as a translator between the user and the computer. It performs basic functionality of translation from one state to another state. So compiler accepts high level language program and it produces the assembly code. So the phases of the compiler are lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and target code generation. Between these phases, there are some information that are required for these particular phases, so they can be obtained with the help of a data structure that is called a symbol table. And if there are any errors are generated in this phase, so they are accepted, they are handled by a separate module that is called as error handler. Now we are going to discuss the detailed description of all the phases. So these phase diagram, they are consisting of 6 phases. So these 6 phases, they are divided into 2 parts. One is called analysis phase and second part is called synthesis phase. So in the analysis phase, we are having lexical analyzer, syntax analyzer, and semantic analyzer. Lexical, syntax, and semantic analyzer we are having. And in the synthesis phase, we are having code optimizer and code generator. So in the synthesis phase, we are having code optimizer and code generator, like that we are having. So lexical, syntax, and semantic, and intermediate code generator, code optimizer, and target code generator. These are the total phases of the compiler program, and these phases are again divided into two parts. One is called analysis phase and another one is called synthesis phase. In analysis phase, we are having lexical analyzer, syntax analyzer, and semantic analyzer, and intermediate code generator. And in the synthesis phase, we are having code optimizer and code generator. Now coming to one by one, we are going to study all these phases. So starting from the first phase of the compiler, that is called as lexical analyzer. So input to the lexical analyzer is the pure high level language program, because before coming to the lexical analyzer, the high level language program, it goes through the preprocessor directive or preprocessor program that includes all the definition of the hash define and hash include whatever the codes are present. So now the high level language program, it is totally converted into high level language after removing the preprocessor directive. So the basic functionality of lexical analyzer is that it reads the source program character by character and group them into a small unit that is called as token. The tokens they are also called as lexemes. So the lexical analyzer is also called as scanner. It takes the input of the preprocessor, which performs file inclusion and micro expansion, as the input, which is in pure high level language, It reads the character from source program and group them into lexemes, sequence of character that go together. Then each lexeme corresponds to a token. Tokens are defined by regular expression which are understood by the lexical analyzer. It also removes lexical error, comment and white spaces. So it also includes comments and white spaces which are present. So basically lexical analyzer works as a function. Lexical analyzer performs the function of grouping the source program into tokens, or they are also called as lexemes. This token formation is with the help of regular expression which understood by the lexical analyzer. And during this phase, if there are any error occurs, so that are called as lexical errors. And the functionality of the lexical analyzer also includes of removing of the comment and white spaces which are present in the source program. Now after lexical analyzer, now the input source program, it is now converted into the group of lexemes or tokens. So that group of tokens, it is the input to the syntax analyzer. So syntax analyzer take input as the group of token. Then that syntax analyzer is also called as a parser. It constructs the parse tree. It takes all tokens one by one and uses context-free grammar to construct the parse tree. So it uses all the syntax analyzer uses context-free grammar to construct the parse tree. The rules of programming can be entirely represented in few production. Using these production, we can represent what program actually is. The input has to be checked whether it is in desired format or not. The parse tree is also called a derivation tree. The parse trees are generally constructed to check for ambiguity in the given grammar. There are certain rules associated with derivation tree or parse tree. So that rules are: any identifier is an expression, any number can be called an expression, performing any operation in the given expression will always result in an expression. For example, sum of two expressions is also an expression. The parse tree can be compressed to form the syntax tree. The syntax error can be detected in this level if the input is not accordance with the grammar. So according to the grammar, it checks all the input. So the basic input to the syntax analyzer is set of tokens, and output from this syntax analyzer is nothing but the parse tree. So parse tree is take. So parse tree, it is again checked by the semantic analyzer, and after that it produces semantically verified tree. So after the semantic analyzer, we are having the next phase, that is syntax analyzer. We are having the next phase that is called as semantic analyzer. So input to the semantic analyzer is the parse tree. So whether it is meaningful or not, it furthermore produces a verified parse tree. It also does type checking, label checking and flow control checking. So semantic analyzer verifies the parse tree, it is meaningful or not. It produces a verified parse tree. It also does type checking, label checking and flow of control checking. Now after the semantic analyzer, we are having intermediate code generator. So intermediate code generator, the fourth phase of the compiler diagram. So what does it produce means it generates intermediate code. So intermediate code generator generates the intermediate code, which is a form that can be readily executed by a machine. We have many popular intermediate codes. Example, 3-address code. Intermediate code is converted into machine language using the last two phases, which are platform dependent. Now, the intermediate code, the basic functionality of intermediate code generator is to generate the intermediate code, and that intermediate code can be executed by the machine. So there are so many examples of the popular examples of the intermediate code, like 3-address code and so on. And that intermediate code then converted into machine code or machine language code or machine language program using the remaining two phases, which are platform dependent. Till intermediate code, it is same for every compiler out there, but after that it depends on the platform to build a new compiler. We don't need to build it from scratch. We can take the intermediate code from the already existing compiler and build the last two parts. So in this way, the intermediate code is basically the phase which is going to produce the intermediate code, and after intermediate code, depending upon the machine requirement, we can change it, and based on that particular we can produce the target code. So that is the meaning of this particular scenario. So the intermediate code is converted to machine language using the last two phases, which are platform dependent. It is same for every compiler, but after that it depends on platform to build a new compiler. We don't need to build it from scratch. We take the intermediate code from the already existing compiler and build the last two parts. It builds the last two parts like that. Now the next phase after intermediate code is code optimizer. The code optimizer transforms the code so that it consumes fewer resources and produces more speed. The code optimizer basically works for optimizing the code, reducing its size and reducing its memory requirement so that it can execute fast. The code optimizer transforms the code so that it consumes fewer resources and produces more speed. The meaning of the code is being transferred is not altered. So here the code optimizer is not going to alter the code, just it is going to make few changes, or so it performs certain transformation on the input code so that it can take the less resources. That code optimizer, again, it can be categorized into machine dependent and machine independent code optimizer. So the code optimizer can be again classified into machine dependent and machine independent code optimization. Now the next phase after the code optimizer is target code generator. The main purpose of a target code generator is to write a code that machine can understand and also register allocation, instruction selection, compilation. The optimized code is converted into relocatable machine code, which then form the input to the linker and loader. So the basic functionality of the code generator is that it is going to generate the code which can be understandable by the machine, and it also allocates registers, instruction selection. The output depends on the type of assembler, This is the final state of compilation. The optimized code is converted into relocable machine code, which then form the input to the linker and loader. All these 6 phases are associated with the symbol table manager and error handler as shown in the upper block diagram. So in the block diagram we have shown that all the phases are there. So that symbol table, it is data structure being used and maintained by the compiler, consisting of all identifiers name along with their types. It will help the compiler to function smoothly by finding the identifiers quickly. So in this way, the phases of the compiler, all the phases of the compiler, they are like lexical analyzer, syntax analyzer, semantic analyzer, and output optimizer, intermediate code generator, and target code generator. Starting from high level language to the assembly code, all the phases they work together for translating our high level language program into machine language program.